I really first want to thank the Horsham Township and the Hatboro Horsham School District for having us here today and providing the high school. We really appreciate it and our coordination the past few weeks for that, and we do thank you for that. And really, from my standpoint, I'd like to say it's been for me. I've in a past position that I had at DEP. Pennsylvania DEP. I was the regional director, so it's all the folks here in this area to our continued collaboration on this important issue. But it's important for me to how familiar I am with it. And now, as my almost a year now as regional administrator for Region 3, that continued collaboration and support for all the localities here on this important issue. And it's important that this information, as we progress forward, how important it is for EPA to have all of you here today, the public, first and foremost, as we continue to share the information that we have. But we have a really full agenda today, and as we have the listening session this evening. So it's a priority for Acting Administrator Wheeler that that goes to the public. That's the priority one for us. So good morning, everyone, and again, welcome to the community engagement event. I am Cosmos Servideo. I am the EPA Regional Administrator for the Mid-Atlantic region, which consists of Pennsylvania, Virginia, West Virginia, Delaware, Maryland, and the District of Columbia. As I said, Acting Administrator Wheeler has been personally involved in this event, and he wishes he could be here today. However, we will be updating him on the outcomes of our 2 sessions scheduled for today. And I know I can speak for all 10 regional administrators. We are so appreciative of Administrator Wheeler's support and leadership on this important initiative and this important endeavor today, the engagement. Today's event follows the PFAS National Summit in Washington, D.C. in May. At that summit, EPA committed to take action on PFOS by developing a PFOS management plan by the end of this year. There are 4 key areas that we identified at the National Summit that EPA is focused on. I think you have seen these action items on posters around the room, and I know that my colleague Peter Gravatt from our headquarters office will go into more detail about those proposed actions. Today, EPA is taking steps to proactively and formally engage the public around the development of a plan to manage PFOS, and we welcome your input. To provide some background information for you, PFOS is a group of man-made chemicals that have been widely used in everyday products since the 1940s. The detection of PFOS compounds in groundwater and soil has raised concerns about potential environmental health risks. Across the Mid-Atlantic region, we have seen numerous sources of PFOS contamination, including firefighting and training areas, manufacturing facilities, landfills, and more. Many of you are here today because in some way or another you have been impacted by PFOS, whether it has been detected in your groundwater, where you live, or where you work. You are here to tell us what you know, and we appreciate that. I want to take this opportunity to recognize our state partners for all their hard work, and I want to thank our communities and community groups for their involvement, cooperation, and coordination with EPA, the states, and our local governments. And we are finding PFOS contamination, as we are finding PFOS contamination in our region. There are listed Superfund sites where PFOS investigations are ongoing. In instances where drinking water is impacted, I believe it's on all of us to help find solutions and ensure that communities have access to clean drinking water. At the former Naval Air Warfare Center, Warminster, the Naval Air Station at Willow Grove, and the Horsham Air Guard Station facilities, we are doing just that. This has been an excellent example of partnership and community effort. There is still more work to be done, but we are making progress. Today, we have an agenda packed with a variety of speakers and panels from across the region to help us gather more information. We have federal, state, and local speakers here to give us a variety of perspectives on how PFOS is being managed in the region. And as I had said, we have some very active, well-organized community members working on the PFOS issue in their communities. And I'm glad to say a few representatives with us to provide context and insight into their work and experiences. And it's, again, continues to be such a priority for the agency to work with all of our community groups. And to see so many of you here today and so many of you that I know, I do appreciate you participating, and I thank you. Today, we are here to listen, not only at a regional level, but at a national level. This is a tremendous opportunity to learn from each other. It's an opportunity for EPA specifically to hear about management practices and experiences that might help us develop our management plan. I think we are going to have a very productive meeting and continue a great working relationship with all of you on this very important and tough issue. My colleague, Peter Gravatt, is going to follow me to dive in a little deeper on the national efforts happening on this issue of PFOS. Peter is the head of the groundwater and drinking water at EPA's Office of Water in Washington, D.C. I look forward to a thought-provoking day. I thank you all for coming. I thank Peter, the entire EPA staff, my staff here in Region 3. It's just a great group of men and women who, as our counterparts at headquarters, who are dedicated each day to protection of human health and the environment. So again, we are excited to be here, to hear from all of you. And again, thank you. And with that said, I introduce Peter Gravatt.
All right, Kaz, thank you so much. And as Kaz said, it is a delight for us to be here with you. This is tremendously important for the agency, for the administrator, for the Office of Water, and for all the regions and our partners across EPA and other parts of the federal family. This is a very important event for us to, as Kaz said, learn from you and understand your perspectives. That's what this is fundamentally all about. And Kaz, in addition to thanking you, I want to thank your terrific staff for helping to organize this event, our friends from the state of Pennsylvania and also other states who are here, and local officials as well. And as Kaz said, we really kicked off this effort with a National Leadership Summit in May. Some of you in the room were here for that event. And one of the key things that we discussed at that summit was our commitment to travel around the country to meet with folks in local communities that have been impacted by PFAS to make sure that we understand what the key needs you have are for EPA, and to make sure that we're responding to those needs to meet the challenges at the local level. The summit included representatives from over 40 states and tribes and territories. We had 13 federal agencies, congressional staff, associations, industry groups, and non-governmental organizations. And of course, the largest group of folks that we most need to hear from are folks here in this room and others around the country. And so in addition to the summit, we're traveling really to all regions of the United States to meet with similarly impacted communities. So at the summit, as Kaz mentioned, EPA, in addition to all the work that we already had ongoing related to PFAS, we made commitments to 4 key actions, which include evaluating the steps to understand whether there's a need for EPA to develop a maximum contaminant level for PFAS compounds under the Safe Drinking Water Act. And we are currently working with our federal and state partners to make sure that we understand everything that is known about PFAS so that we can best and most carefully evaluate all the different issues around development of a maximum contaminant level. The second item that EPA committed to at the summit was to begin the steps to propose designating PFOA and PFOS as hazardous substances under the Superfund Act through one of the various statutory mechanisms to do so. The reason why this action is very important is that under Superfund, unless a substance is listed as a hazardous substance, EPA doesn't have the ability to order actions under Superfund or to recover costs that EPA may expend in cleaning up contaminated site. So it's a very important step, and we're currently in the process of evaluating the path towards designating these PFOA and PFOS as hazardous substances. The third commitment that EPA made at the National Leadership Summit was to develop groundwater cleanup recommendations for PFOA and PFOS at contaminated sites, and we will be completing that task this fall. And then the last is working very closely with states and other federal agencies. We are developing toxicity values for additional PFAS compounds, GenX and PFBS. That's happening as we speak. In fact, those draft toxicity values right now are undergoing peer review, and they will be posted for public review and comment by the end of September of this year. So 4 very important actions. In addition, in the National Leadership Summit, there was an opportunity for the participants there to share broad perspectives around challenges with PFAS, and to share information around how states and local communities are currently monitoring for PFAS and steps they're taking to address contamination. And there was also a discussion about risk communication, which is a very challenging area for compounds like PFAS, emerging contaminants, making sure that we have effective ways to talk about both what we know and what we don't know with these compounds. And as I said, the National Leadership Summit laid the groundwork for these community engagement sessions that we're having. And just a couple of maybe high-level summary points that we heard from the summit. This is not comprehensive, but just a few things to point to is that it was clear that there was a great deal of interest in enabling more sampling and monitoring to occur across the country. You're aware that in a number of areas like Horsham, there has been quite a bit of monitoring done, but there are lots of areas where that monitoring has not occurred, and there's much more that needs to be understood about the extent of the challenge with PFAS compounds in the environment. There was discussion about the importance of regulatory backing, is what folks referred to, having regulations in place that will enable additional actions related to PFAS, whether those regulations relate to drinking water standards or other regulations like listing as hazardous substances. People at the summit recognized that private wells is an important gap. We don't have authority under the Safe Drinking Water Act to address private wells, but it's a very important area for us to understand and to take appropriate actions to protect public health related to contamination in private wells. Folks recognized the complexity that comes with a group of compounds like PFAS that are both in such wide distribution in commercial products and in the environment, but also as such a large family of compounds, of thousands of compounds, of which there's relatively few that we have a very thorough understanding of in terms of toxicity. And there was also a broad recognition that we need to be working with stakeholders at all levels, federal government, state government, local government, and individual members of communities in learning how we best address these issues. So those are just some of the very high-level points that I wanted to recognize from the summit, and then to emphasize that that was a first step, and this one is every bit as important, if not even more important, than the national summit, is hearing from you and local communities. That's what this event is all about. We know that some of you are here not just this morning, but will be here into the evening, and I think you'll be joined by many others from the community. And we, as Kaz said, we are very grateful from EPA for your willingness to join us here and to share your perspectives. That's really what this is all about. So thank you very much for that. And I should also mention that EPA, for those folks who either have not been able to participate in community engagement sessions or may have additional information that they'd like to provide beyond what you'll be able to provide here at this session, we've opened a docket, and we have information available here for how you can submit written information to the docket. You may well have more information to share that'll be very important for us to understand. So with that, I'm going to introduce my colleague Andy Gillespie, who's here from the Office of Research and Development. And Andy is the Associate Director for Ecology at our National Exposure Research Laboratory in North Carolina, Research Triangle Park, North Carolina. And since December, Andy has served as the executive lead for all of the work on PFAS that our research program is doing. And Andy, going back to 2004, has served in a number of senior executive and senior leadership positions in EPA's Office of Research and Development. So Andy is perfectly positioned to lead this effort, and we're really grateful, Andy, that you're here as well. And so to turn it over to Andy Gillespie.
Thank you, Peter. Well, good morning, everybody. And as Kaz and Peter both said, I'm also very happy to be here today. When you lead a research program, it's always good to hear, from the people that are actually being impacted by the different lines of research and by the efforts that are underway. So I'm looking forward to learning a lot today. I'm going to speak about the integrated research program which EPA is conducting right now on these PFOS chemicals. EPA has been doing research on PFOS chemicals for many years, going back literally for decades. Primarily, initially, at first, it was on the older chemicals, as we sometimes call the legacy chemicals, PFOA, PFOS. But more recently, we've been putting together a program to deal with this really very large number of interrelated chemicals with very complex chemistry and, in many cases, unknown behavior in the environment. And so what we've got, next slide, please. Go ahead, one more. Yep. I'm going to touch briefly on several different lines of effort that we have. It's an integrated research program. At the end of the presentation, there's a slide that shows the website where you can get more details if you're interested on any of these efforts. But the main takeaway message I hope to give today is that we do have an integrated program and that we're looking at different aspects of the PFOS challenge. We're looking at the different kinds of information that people would need to make informed decisions about understanding risk, and then what to do about the risk, how to manage it, how to clean things up. And it really is very much with a practical applied focus. We're trying to develop data and tools which people, such as in the communities in Horsham or at the state level or in other federal agencies, can use to make actual decisions about managing risk on the ground. Next slide, please. So the first line of research I'll talk about briefly is analytical methods. I mentioned a moment ago the chemistry is very complicated with these chemicals. There are literally thousands of different PFOS chemicals potentially out in the environment. We don't necessarily know all of the different transformations, the way those chemicals can change under different conditions. And one of the first things we need to know if we're going to study PFOS chemicals is how to measure them in the environment, how to quantify in a sample of water or soil or air whether or not a PFOS is present and how much of it is there. And so the problem that we have right now is that there's a lack of standardized and validated analytical methods for gathering consistent data about PFOS. The action that we're undertaking is to develop and to test and publish different analytical methods for detecting and quantifying PFOS in all of the different media, in air, in water, and in solids. So we currently have underway an effort to update our drinking water method for 6 additional PFOS chemicals. We have a standard method that covers 14 PFOS chemicals. We're testing to see whether that method will also work on 6 of the newer generation chemicals. We've got a concurrent method looking at 20 different PFOS chemicals in what we call non-drinking water. So surface water, groundwater, other kinds of water, and also in solids. So we would have a corresponding method for quantifying PFOS in different types of waters. We're starting the initial development for quantifying and measuring PFOS in air emissions. There are times in factory settings, industrial settings, where a certain amount of PFOS goes up a smokestack, and we want to be able to identify what's there and how much of it. And then we're continuing development on what we call non-targeted methods. These are methods for identifying all of the unknown chemicals that might be in a sample. The more common methods that we use are what we call targeted, where you're looking for a specific compound in a sample, but it doesn't tell you what's not there. And our non-targeted methods will help us to figure out what exactly exists in samples so that we can discover essentially new PFOS chemicals that we might not be aware are in the environment. And the impact on this is that stakeholders will have reliable analytical methods to test for known and for discovering new PFOS chemicals in a variety of environmental media. Next slide, please. Okay, exposure. So exposure science deals with how chemicals move in the environment from a source to impact what we call a receptor. A receptor could be a human, it could be a part of an ecosystem. But it has to do with essentially what is the dose that a person or an environmental aspect is being exposed to. There's a general lack of knowledge on all of the different sources of PFOS, how much and what kind is out there, and what are the site-specific concentrations, and what are the different pathways by which PFOS move through the environment to impact people. So we're developing and we're testing methods to characterize and describe PFOS sources and exposures. For example, one thing that we're doing is developing what we call exposure models for identifying and quantifying PFOS exposure pathways. How much PFOS is moving through the air, how much is moving through the water, where are people exposed? Are they exposed in their homes through dust or through food? There's many different ways, because PFOS chemicals are used so widely in so many different products, many different ways that people can come in contact with them. And so part of our research is to try to quantify that and evaluate what's the relative importance, the relative amount that moves through each of those different pathways. And this will let risk managers focus on addressing really the most critical problems first. We're looking at ways of developing sampling and site characterization approaches to identify the sources and the extent of contamination. Before this meeting, I read up on some of the work that's been done here in Horsham, and there are some complicated studies of how the chemicals have moved into the groundwater and where the plume is going and at what rate it's moving. That's the kind of information that we seek to get in exposure science so that we can understand what is the true magnitude of a problem and where it might be going. And the ultimate impact here is that stakeholders, decision makers, would be able to assess the potential PFOS, the sources and exposures that are most important in a given situation, and then take action on to manage the risks. Next slide, please. Toxicity. So there's a general problem right now that we have a lot we call toxicity values for many PFOS compounds. When we say toxicity value, this is a scientific assessment that arrives essentially in a daily dose, how much of a chemical one can be exposed to, for which there's scientific evidence that there might be some possibility of harm. It doesn't mean that a person is absolutely going to get some kind of adverse effect, but at least the possibility is there based on scientific evidence. Toxicity values are needed to make a whole variety of risk management decisions. For example, you'll hear more today about the health advisory levels, 70 parts per trillion. Numbers like that are based on toxicity values, rigorous scientific assessment of the science. We have toxicity values for PFOA and PFOS. As Peter mentioned, we're developing some additional ones for 2 additional compounds, Gen X and PFBS. But beyond that, there's not a whole lot out there in the published peer-reviewed literature for making these kinds of decisions. And so we've started work on this. We've done a literature assessment of all of the literature that's available for 31 PFOS compounds that we believe are going to be relevant to the EPA's mission and to states, to try to find out how much scientific information is out there that could be used to derive toxicity values. But recognizing that there are literally thousands of these PFOS chemicals potentially in the environment, we're never going to be able to get enough traditional, what we call in vivo or animal kind of study data to make these assessments. And so we have to complement this by applying some of our computational toxicology techniques. In computational toxicology, rather than doing studies on whole animals over 90 days in a long period of time, we can study different chemicals with what we call different assays, essentially cell cultures of kidney cells or liver cells or different kinds of cells. And we can try to make some inferences about which chemicals might be activating or disactivating certain pathways in certain kinds of cells. And it just helps us kind of screen the problem and really focus our future efforts on a smaller subset of chemicals where there's a greater possibility for some kind of biological activity. So the results to date of those 31 chemicals, we found about 21 of them where we think we have some sufficient data to support some kind of toxicity assessment. We have assessments underway for 2 of them, and we have a study underway right now in our computational toxicology, conducting assays for 75 different PFOS chemicals throughout the chemical space. When I say chemical space, there's many different categories, many different kinds of PFOS chemicals. What we're trying to do with this first cut of 75 chemicals is look across the entire space of thousands of chemicals, getting some samples from different groups within that space, and just trying to get some first approximation data of what kind of groups of chemicals, what sort of chemical structures or physical moieties might cause potential biological activity so that we can further focus our studies in the next round of assessment. And the goal here is that stakeholders will have PFOS toxicity values and toxicity information for helping to make decisions about where some further activity needs to take place. Next slide, please. Drinking water treatment. So once we understand that we have a problem in drinking water, we need to manage that risk in some manner. An important part of that science is to understand what are the different engineering solutions that can be used to address or remove PFOS chemicals from drinking water. So the problem here is there's a general lack of water treatment technology performance and cost data. There's often trade-offs between performance and cost for PFOS removal. This information is critical for utilities, for other organizations that are in the business of producing safe drinking water for communities. We have information for, again, the legacy compounds, PFOA and PFOS, but we're still missing information for many of these newer compounds. So the action underway right now, largely being headed up by our laboratory in Cincinnati, Ohio, which has a tremendous concentration of expertise in PFOS and water treatment work. We're reviewing a variety of performance data from all kinds of sources. There's many different industry groups that are doing tests and trials of the effectiveness of different technologies for PFOS removal. Department of Defense is supporting a lot of this work. There's a lot of work being done in different universities, academic institutions, and internationally as well. We're trying to gather all of this data, synthesize it, weigh through it, and then adding to that by testing some of the commercial solutions right now that are available. There's two in particular that we're focusing on doing some laboratory tests on. One is called granular activated carbon, GAC, or GAC, which is shown to be effective for some of the older generation, the PFOA and the PFOS chemicals. And we're testing to see whether they're also going to be effective for some of these newer formulation chemicals. And then ion exchange, i.e., these are different kinds of resins which have also proven effective for the older generation, trying to see if they're going to be equally effective for the newer generation. And we're also looking at testing a range of system sizes, everything from a large drinking water treatment plant that would support a community, such as Horsham, everything down to eventually, hopefully, a complete set of assessments looking at potentially point of use or point of entry filters, single home or single faucet kinds of filters. And the results of this would be updated into EPA's drinking water treatability database. This is a database which is already online, it's been there for many years, that provides synthesized scientific information for different chemicals and different kinds of treatment technology so that utilities and others can go in and search on a given chemical or search on a given technology to see what it might or might not be effective for. And then using some state-of-the-science models to try to extrapolate what we do know into filling in some of the gaps for places where we don't have as good a data. And so the impact here would be that utilities will be able to identify cost-effective treatment strategies for removing PFOS from drinking water. Next slide, please. So in addition to drinking water, we know that we have to take some actions to help clean up contaminated sites. There's PFOS contaminated sites that are contaminated for a variety of reasons, perhaps industrial purposes, perhaps from use of the aqueous film-forming AFFF, or the film-forming firefighting solutions. And those sites need to be cleaned up and treated to protect human health and the environment. So the actions here are to characterize the different sources. So PFOS, because they're so ubiquitous, can come from many different places, such as fire training, emergency response sites, manufacturing facilities, production facilities, disposal places such as landfills. Many different kinds of sources of PFOS exist, and they all have potentially implications for how you would go about cleaning up and treating such a site. So we're looking at different treatment technologies for remediating the PFOS impacted soils and waters and sediments. And again, generating performance and cost data, working with collaborators to try to develop models and tools for figuring out the best way to treat a given site, to clean up a given location. The result here would be tools and data and guidance regarding the cost and the efficacy trade-offs, and ready for implementation for cleaning up particular locations. The impact would be that responsible officials at whatever level would know how to reduce and how to manage the risk of PFOS exposure and PFOS effects at contaminated sites, and to repurpose those sites for some kind of beneficial use. Next slide, please. Materials management. We used to call this waste management. We're trying to get away from that term and recognize that many of these are materials that can be repurposed, reused, recycled in some manner. But because the PFOS chemicals, one of their properties is that they're very durable. They last a long time. They will often last longer than the life of the actual product they're used in. And so at the end of the life of the product, you still have a product which you're ready to dispose of in some manner, but still may have PFOS in it. So there's a lack of knowledge regarding the end-of-life management practices, whether it's best to use landfills or incineration or some other means for PFOS-containing consumer and industrial products. So the actions here is we're trying to characterize various end-of-life disposal streams. So you have municipal waste streams, industrial waste streams, manufacturing, landfills, and then looking at different treatment options, such as incineration and recycling, for where PFOS can potentially enter the environment. We're trying to evaluate the efficacy of current and advanced waste management technologies, thermal treatment, composting, stabilization, to manage PFOS and prevent further problems at the end of the life during the disposal. And again, evaluating the performance and the cost. Any time that we're looking at some kind of a treatment method, you have to consider the trade-off between how effective it is in your objective, but the cost is also a factor because it has to be paid for by some group or some entity. So looking at the evaluation of the performance and the cost data to provide decision makers with a range of tools so they can understand those trade-offs and make good decisions. So the result would be to provide technologies and data and tools to help manage better the end-of-life disposal streams. And the impact would be that responsible officials would be able to manage effectively the end-of-life disposal of PFOS-containing products. Next slide, please. Technical assistance. Because of all the different steps, the measurement, the analysis, understanding the exposures and the toxicity and the options for remediation and treatment and cleanup, there's a lot of complexities here, and many states and tribes and communities sometimes lack the full capabilities for managing that entire spectrum of information needs for PFOS. And so part of our mission at the EPA is to provide technical assistance to states and tribes and communities to help you manage these situations in line with your local needs. So the actions here is we make EPA technical staff available to consult on PFOS issues. We've been working with a variety of states and other organizations trying to understand and test different methods and tools. We utilize applied research at impacted sites to develop new research solutions while also providing technical support. This has been very much a two-way street. Some of our most impactful research has actually been done in collaboration with communities, with states, with industry, or with DoD on particularly impacted sites where we have the latitude to try different things, to see what works, and really try to focus on getting the best treatment for that particular situation. And then to summarize recurring or common support requests to share the lessons learned so that everybody doesn't have to start from scratch when they have a particular situation. And we have many projects underway right now, active collaborations. I've listed 3 of them up here on the screen. So we've been working with the state of North Carolina in the Cape Fear River Basin for the last couple of years. A situation they had there where a manufacturing or an industrial facility was putting some PFOS into the water supply, which was going downstream, which was being taken in by a major city and impacting their drinking water supply. Working with the state and with the EPA region, we've had a significant impact on reducing the PFOS in both the source and the finished drinking water in North Carolina. We have an active collaboration undergoing right now in Manchester, New Hampshire, where, again, working with a facility and working with the state, looking at both integrating the air and the water waste and trying to understand the full fate and transport of how the PFOS moves from the source through the environment. And then in Newport, Rhode Island, a case where we're working and supporting the Department of Defense who are conducting PFOS sampling at a naval station in Newport. And so the impact here is really to enable states and tribes and communities to take action, to help you all make full use of the tools and the data that EPA is developing and apply it to your particular situation. Next slide, please. My final slide here, this is just a screenshot of the EPA PFOS Data and Tools website. So if you go into the EPA PFOS website, or if you just Google EPA and PFOS, you'll find that one of the pages there links to a set of data and tools. As we develop new science, as we develop additional databases or models or methods, we will be posting links on this website. So at any point, if you're interested in what we have available, you can always go there and find out more. And that website also includes links for contacting EPA if you have particular questions or if you'd like some more information or something. And I would encourage you all to take full advantage of that. So with that, I think I'll stop and pass it back to
Thank you very much, Andy. Thanks for that information on the research that EPA and others are performing. I think now we're going to start the panel, so we'll sort of transition and have the members of the federal panel come up.
We understand it's a little bit difficult for people to hear in the back of the auditorium. It's because these speakers aren't really able to push sound up underneath the balcony. So if you're having some trouble, please move forward. You'll hear a lot better And anyone coming up as a panel member or speaker, try to make sure that the microphone is relatively close to your mouth so that everything will be picked up a little bit better. We really appreciate the Hatboro-Horsham School District for hosting us. Maybe you don't know, but they're redoing their sound system, and they were kind enough to get a portable one in for this event today. So if you are having trouble in the back of the room, please move forward and you'll hear a lot better. Thank you.
Very good.
Okay. Good morning, everyone. My name is Cecil Rodriguez. I'm the Deputy Regional Administrator for EPA region, the Mid-Atlantic region, and welcome to the first of our panels, the federal panel. This panel of distinguished guests will share with us some context and insight into their experiences with PFOS and the challenges their agencies have faced as they deal with PFOS issues. Joining us on the panel, to my immediate right, is from the Management of Natural and Cultural Resources, Cleanup of Contaminated Sites, Safety and Occupational Health, Laura Werner. She's the Regional Director of ATSDR Region 3 Office. She joined ATSDR in 1999 as an environmental health scientist, and in 2005 was promoted to manage the operations in the Mid-Atlantic region. She is responsible for overseeing the regional staff and public health review of hazardous waste sites and chemical exposure concern in the Mid-Atlantic region. Many of you are familiar with Laura. She has been working closely with this community over the past years. I want to thank all of you for being here today, and your input is critical to understanding the way the agency can best support the work that has been done by our partners. And I will turn it over to Maureen. Thank you.
Thank you, Cecil. Good morning, everybody, and I want to thank you, Cecil, for including me in this session. I really appreciate it. I was at a similar session in New Hampshire with Peter, and I found it very informative, and I look forward from hearing from all of you later today. My intent in being here is to listen and learn from all of you. I'm going to give a really short overview of what the Department of Defense is doing across the entire Department of Defense portfolio. So I'll give a quick highlight on what we're doing in drinking water, both on our military installations and off, and groundwater, and then I'm going to wrap up with some discussion of challenges. Next slide, please. So let me start with drinking water on our installations. For the installations that we manage, we were also subject to the unregulated contaminant monitoring rule number 3 back in 2015. 63 military installations around the country met the criteria to be included in the rule. We had one installation, Wright-Patterson Air Force Base, that exceeded the lifetime health advisory of 70 parts per trillion, and the numbers are up there at what they found. As you all appreciate, what EPA issued was an advisory, so we had to make a decision within the Department of Defense what we were going to do, and we made the choice from a policy perspective to test for PFOS and PFOA at all DoD installations worldwide where we are purveyors of the water. Now, I'll be honest with you, not all of our bases actually produce and distribute their own water. A group of them buy water from the local municipality, so distinction there. We operate 524 systems worldwide, which we tested. 24 tested above the lifetime health advisory, and we took the actions as EPA's Office of Water indicated. As a continuing thing, we also, where we buy, we asked the local purveyors if they tested, and I think the Navy actually, I shouldn't say I think, the Navy actually voluntarily tested where they were buying water, so that was one thing. Concurrently, then, next slide please, we also said we need to go out, We've been in the cleanup program for many years. We know a lot about the water on our installations. So could we go out and actually start identifying where we had a potential release and figure out a suspected or known release and figure out if we had a belief that it would have gotten into the drinking water. And told the military departments to go out and identify those locations if there was a strong belief that it had gone off base into somebody's drinking water, to ask for rights to test that water, because it's not our water, we have to ask permission. And if so, if in fact it exceeded the 70 parts per trillion, to work with the owners of the communities to address that. You can see the statistics up there. Oh, this is the data as of August of 2017. We haven't collected, although that information is continuing to be updated, I haven't collected it for the entire department worldwide. But that information through August 17th is available on the web at this site, base by base, exactly what we found, what the results were, and what the installations are doing to address it. So there's a lot of information on the website available there. Next slide. So the next step was, okay, now that we've taken the steps to cut off human exposure through drinking water, now we actually have to go through the CERCLA process. So the department has identified 401 installations across the nation where we have suspected releases, at least one area known of suspected releases. So we have to follow the CERCLA process. So the military departments are out there doing what we call site investigations to figure out where we have had releases, known or suspected releases, what are then the next steps that we have to do. I will say that this is a complicated process. It is a very methodical process that's established under CERCLA, so this takes time to go through, but each of the military departments have stepped up to do that, to go through that process in partnership with the state regulators and with EPA, and make sure it is, in what I've said, is being totally transparent in the process is what I want everybody to do. I will, to follow on Andy's comments earlier, we have also invested a lot of money in research and development associated with the cleanup requirements that would be required to remediate these sites. To date, it's been $40 million in R&D, and I don't see an end to that. We have a very healthy website under our Strategic Environmental Research and Development Program that has all of the information about studies that have been completed, studies that are ongoing, and upcoming studies. So again, highly technical, but very thorough, robust website that if you have questions, I encourage you to look at. Next slide. So Here are listed some of the challenges that we in the department are facing associated with this. And some of them are not unique to the Department of Defense, and I just want to share with you, we're trying to work through all of these things to be able to make sure that we are doing the right thing. So one of the challenge, I'll start right at the top, is the EPA's Office of Water has issued the Lifetime Health Advisory for PFOS and PFOA, and of course we're following what they're doing with the toxicity values for the 2 additional substances. But how does that information roll into the CERCLA process to determine an unacceptable risk? We are anxious for EPA to issue the guidance document that Peter referenced earlier. We think it will help clarify for everyone how to proceed under the CERCLA process. If you're familiar with the CERCLA process, this is essential information to make sure we're consistently moving from the site investigation into the remedial investigation feasibility studies, which give you all the details about what's going on in the site and what the path is to come up with an actual remedy for it. Risk communication, I don't think you need to hear more from me about the challenges associated with risk communication. We're facing the challenges that everybody is how do you talk about this and how do you explain the risks? We are looking to groups like ATSDR and EPA for their guidance because they're the expertise in risk. Peter talked about the going through the process to evaluate an MCL. We have been saying we support going through the process. I think that. The other thing is, as many of you are experiencing, each state is actually taking efforts separately. And of course, the Department of Defense is in all 50 states and as well as the territories. So we are really working hard to stay up with what is going on in each state and making sure we fully understand how that state regulation feeds into the CERCLA process so that we are actually doing what we have to do. There's a lot going on right now, as you can appreciate, so it's a big effort to keep current in all these efforts. A couple of other quick things. First of all, Congress has put in the Department of Defense National Defense Authorization Act a direction to ATSDR to conduct exposure assessment and health study. But for the Department of Defense to provide $10 million in fiscal year 18 to do a study on PFAS and PFOA, sorry, I apologize. We are in the final signatures of the agreement this week, and so I'm hoping to be able to move the dollars next week to ATSDR for them to start that effort. It's been a little challenge, and I'll get to that in terms of my last bullet. But the good news is Congress, so for those of you who don't live in Washington, D.C. and have to live with the congressional process that I live with every day, is every year Congress passes a National Defense Authorization Act, which is an act that tells us, Department of Defense, what we can do in the next fiscal year. So Monday night, Congress voted on the fiscal year 19 Act. And the good news is they gave us new authorities so that we can directly transfer the money to ATSDR instead of going through a whole negotiation process. And the way we're giving it to ATSDR is going to give them a lot more flexibility. So we appreciate the congressional process. One thing I want to say on this exposure assessment and health study, it is up to ATSDR to select the military installations that will be included in that study. We are providing data that they are requesting, but it is up to them to do the selection criteria and actually select the sites. A couple of things I want to highlight quickly, and I'm sorry for going so long. You know, Andy mentioned this disposal of the carbon, the materials management is a concern for us. We are working on researching the AFFF that does not have PFOS, PFOA. We're working with manufacturers. The Navy is working with manufacturers to demonstrate various ones to see if they'll meet the standard for how quickly they can put out a fire. Plus, we've invested we've invested money in research for a completely fluorine phone. Now, this is basic research, so it's going to take years because it's bench scale, but we need to start. The sooner we start, the better. Now, one of the things, the last thing, and I have one good news I want to share with you is a challenge for us has been the congressional process of when they give us the money. So again, you probably don't have to deal with Congress the way I have to deal with all the things. Congress has not passed a full appropriations bill at the beginning of the fiscal year, October 1st, for almost 10 years, if I recall correctly. That means they give us money in dribs and drabs. And so we'll get a little bit of money for 3 months, and a little bit of money for 6 weeks, and a little bit of money for another couple of months. And then suddenly in March, they'll give us the entire year, and they say, okay, we've given you the money in March, and you have to spend 80% of it by the end of July. And if you don't spend 80%, we're going to take it away, everything else away from you. So we're forced into this in a hard way. So the money doesn't flow as smoothly, and that impacts things. And we've expressed that concern to Congress. But I want you to understand that we empathize that sometimes the contracting doesn't flow as quickly and efficiently as we like. And a big part of that is how we get money. So the one thing I want to close on is some good news. In this Defense Authorization Act that Congress passed on Monday night, the President hasn't signed it yet, so it's not actual law. There is a provision that requires the Department of Defense, the Secretary of Defense, to do a assessment of the health effects of PFAS exposure for individuals who served as members of the armed forces and were exposed to PFAS in their careers. It's going to go on to talk about how to work with, the study needs to address how we would work with the Department of Veterans Affairs and developing a registry. That is a new requirement that is in the bill that we hope the President will sign soon. Last slide. So I want to convey to you that we are taking this very seriously in the Department of Defense. We want to move out quickly and efficiently within our resources, within our statutory capabilities. Our priority is to protect human health, and so the priority is to cut off exposure to people drinking the water. And I think the military departments have done a really good job for that. We are looking for substitutes, but I appreciate that this is a very complex situation, and we're trying to stay up with everything that is going on. Again, thank you for including me, and I really look forward to hearing from all of you later today.
Good morning, everyone. My name is Bill Sabolis, and as Cecil indicated, I am the director of the ATSDR Division of Toxicology and Human Health Sciences. And I'm delighted to talk to you for a few minutes about what's going on with ATSDR. So, first of all, I want to thank EPA and my friend Peter Gravad and others for inviting us to this meeting. At ATSDR, we know the importance of community engagement and community involvement. It's critical to our work at sites, and without it, we can't be successful. So we find these meetings very important. Like Maureen, I too was at the meeting in New Hampshire, learned a lot, and look forward to hearing from you later on today so we best understand what your concerns are and what your needs are, and how we as a federal family can help address those. Peter mentioned at the May summit that just occurred, there were at least 12 federal agencies engaged there. I can tell you in my 30 years of working at ATSDR, I have never seen the federal family pull together on an environmental health issue as we're doing on this. And everyone has their specific responsibilities and mandates, and I think we're all really pulling together and helping each other out. To that end, ATSDR, we strongly support EPA's role and responsibilities and authorities to provide drinking water guidance to states and local health departments. And also, as we've looked at the 4 actions and priorities that came out of the summit that are on the poster boards in front of you, we strongly support those actions also and look forward to helping EPA accomplish those actions. So ATSDR, if you don't know, we're a small agency. So we're 275 staff. We're co-located with our colleagues at the Centers for Disease Control, the National Center for Environmental Health in Atlanta. We were created in 1980 under the Superfund Act. We have really 4 major responsibilities that CERCLA requires of us. One of them, the most important probably of which, is to conduct public health assessments for communities that are impacted by wastes in the environment. And this is really where the rubber meets the road for ATSDR. And my colleague Laura is going to talk to you a little bit about what's going on with your sites here in Region 3. Also at ATSDR, the other 3 mandates, sort of real quickly, we're required to do health studies. So to the extent that we get into a community and we agree that doing some sort of human health studies, exposure assessments and health studies will help us address the issues a little bit better, we're mandated to do that. We're also mandated to conduct to develop toxicological profiles, and I'm going to talk about that in just a little bit. I think most of you know that ATSDR just released an 800-plus page document that describes what we know about the exposure and toxicology and epidemiology of 14 of these PFAS substances, and I'm going to talk about that in just another second here. And then finally, we have a mandate to provide health education. So that's health education for both the communities as well as for the health providers. We find many times that we work in a community and the health providers don't know about what's going on in their communities and to be able to deal effectively with their patients and things. So we have a very strong mandate and we work very closely with the health providers to provide you with that education that will help the communities deal with their exposure problems. So I wanted to give you just a real quick timeline update before I talk about the tox profile to show you that, like EPA and others, this is not a new issue for us. The CDC National Center for Environmental Health has actually been measuring PFAS in human serum since 1999. In the mid-2000s, ATSDR began its first community public health assessments. That has grown to where, at this time, we are engaged in sites in every region of the United States. As many as 30 or 35 sites we're actively engaged in at this time, so that continues to grow. As for the toxicological profile, this document, which has just come out for the 3rd time for public comment, we actually started that document in 2007. And I'm going to tell you again just a little bit more about why it's taken so long and where we are with that document. And then finally, I wanted to point out, as far as just a little timeline goes, it was really about 2015, 2016, where we began talking a lot and recognized, as Peter had indicated earlier, that there is a need for more exposure data. We need a better understanding of what's in the environment and the levels people are being exposed to. And we also started talking about health studies. There does seem to be a lot of inconsistency in the information that's out there, and we needed some good quality health studies to be able to sort out some of these inconsistencies. And I want to tell you a little bit more about that in just a second. Okay, so I want to start with the tox profile. This document, as I said, has just came out. It was released by ATSDR on June 21st. It was originally released for a 30-day public comment period. This is the 3rd time it's been released for public comment. We just recently extended that public comment period for another 30 days to give organizations, community members, agencies, our colleagues in the Department of Defense and others to have adequate time to comment on it. To date, we've received 26 comments, but I know as as August 20th comes around, we'll see lots more comments coming in. So that document, just to make you understand how the process works, as we look at those public comments that have come in, if there is something very significant about the science in that document, we may make a decision to go out for another round of external peer review. We want to make sure that document has the best science, the best evidence-based science that's available right now. Now, the literature is evolving on these substances, as you can imagine. We receive probably hits of 20 to 25 new studies every week, and we're trying to keep up with them. As I said, it's a large document at this time, covering 14 substances. As I said, we know in the next couple of years we're probably going to have to update that document again, because the literature and the science is continuing to evolve on these substances. Now, in these documents, ATSDR has a mandate to identify levels of significant human exposure. Okay, and we do this by generating what we call minimal risk levels. And a minimal risk level to us is basically the amount of a substance one can be exposed to on a per day basis without an appreciable risk to health. Okay, I said we have 14 substances that we've highlighted in this particular profile. For 4 of them, we felt that the science had enough information that we could develop these minimal risk levels for 4 of the substances. 2 of them are PFOA and PFOS. So those numbers have actually been updated since the last version of our document. And then we have 2 new substances that we felt that we could develop minimal risk levels for. And those were perfluorooctane sulfonic acid, the 6-carbon PFAS, and then also for the 9-carbon PFAS, perfluorooctanoic acid. I think I put one too many syllables in there, but so those are 2 new substances that we felt the science was available for us to generate minimal risk levels. And I just want to explain how we use those numbers at ATSDR and how our partners in the states use those numbers. First of all, we're not a regulatory agency. Okay, these are not regulatory standards. How we use these numbers basically are as a screen. So we'll go into a community and we'll assess exposure to PFOA and PFOS if it's in your drinking water. We'll look at what levels are in the water. We'll look to see where there are other exposure sources possibly around. We'll look at vulnerable populations in the area. We'll look to see if those are levels measured at the tap or in the drinking water, if there are filtration systems available. But we'll estimate exposures in a community and then compare those estimated exposures with this screening level or minimal risk level. And if our estimated exposures are below our minimal risk level, well, we feel generally pretty good that there should not be any health effects associated with those exposures. But if our estimates exceed our minimal risk level, it means to us that we need to take a better look at just what's going on in that community. So again, it's not a threshold or a bright line where you can separate those below and those above, where those above would be expected to have health effects. That's just not how we use those numbers. They're used as screens, and I think it's very important that we all understand that. And then I want to talk just a few minutes before I turn the mic over to Laura about exposure assessments in health studies. And my friend Maureen set us up here pretty good for what's happening here. So with funding from the Department of Defense this year, we are going to try to put a dent in that issue of what do we need in the way of exposure assessments to better understand levels in the environment and how they translate into human serum levels. And so with that funding that we're getting this year, we will be conducting exposure assessments at least 8 current military or former military installations. The progress on that is moving along quite well. We have a protocol in place. We have questionnaires in place. We know how we are going to recruit people. We are thinking carefully about risk management and risk communication and how that will work for these exposure assessments. If you're following us, you would know that in July of 19, just last week, we actually published a notice making that protocol, the questionnaires, the consent forms available for public review. This is a requirement by the Office of Management and Budget, so we're well along with this process, and as soon as we actually have the money in our checking accounts, we'll be able to actually go out there and start this. But I can assure you we're ready to hit the floor with the exposure assessments just as quickly as that takes place. Now, with the health studies, with this year's funding from the Department of Defense, we are actually going to start work at a community that we have been engaged with for several years now, and that's the Peace International Tradeport community in New Hampshire. We have, over the past year, developed the feasibility assessment and turned it into a research protocol on what could be accomplished in studying just the population at Pease. We will use what we learn at Pease to help inform and develop a protocol for a national, or I should say a multi-site study. So our intent or our hope is to get continued funding from the Department of Defense, where we will conduct these health studies in additional communities, depending again on the funding and our ability to get this moving as quickly as we can. But again, the funding we have right now will allow us to start the work at Pease. We'll be able to sort of test drive the protocol that we'll be using for the multi-site study when we get funding for that, hopefully next year. And so we're looking forward to that. Maureen mentioned that ATSDR will have the authority to pick the communities. We are expecting that to be a cooperative agreement, if you will, and give communities, health departments, and others the opportunity to be able to provide us proposals and to be able to look at it through that. So we have not picked the communities yet. It's a process that's still under deliberation, and we look forward to, again, hearing advice from you and others about the multi-site study and as it develops, and you'll again have an opportunity to comment on the protocol and the way that it will be conducted. And with that, I'd like to turn it over to Laura, who's going to talk a little bit about what's going on here in Region 3.
Okay, thanks, Bill. Can you hear me okay? Okay, great. As Bill mentioned, ATSDR is working in communities all over the country, but my job was to share a little bit about what we're doing here in Region 3. And also, as he mentioned, we're really tiny, so everything we do is in partnership with the state and local health departments in these jurisdictions. In Region 3, we've been providing public health support in Delaware, Maryland, Pennsylvania, Virginia, and West Virginia. And details about this, they're all on ATSDR's website. It's really easy if you just Google ATSDR, PFAS, all of this information is there, including the toxicological profile that Bill was mentioning. If you want to see that and review that or provide us comments, that's there. There's also resources like talking to your doctor about PFAS. You can find a fact sheet you could bring to your doctor's office, for example. There's fact sheets describing the levels of PFAS in people's blood across the country using that NHANES database that Bill mentioned as well. So if you need any of those things, again, they're all on our website. But in Delaware and Maryland and Virginia, we've primarily provided our support in public meetings and in one-on-one support to residents. In West Virginia, and those sites were NASA Wallops in Virginia, the Bracino Plating in Blades, Delaware. In Maryland, it was the Naval Research Laboratory in Chesapeake, and in Virginia, it was Fentress and Oceana. So just a wide range of different sites and communities. West Virginia, our support has been to the state and EPA and academic partners back with the Washington Works DuPont facility in the past. In Pennsylvania, that's where the bulk of our activity is. Right now, we're working with a lot of community members and agency partners and academics and health professionals around the Willow Grove and Warminster former facilities. We did a letter health consultation report that evaluated the public health implications of the contamination in the public and private drinking water supplies near the Warminster site. That report's available on our website, and I have some copies too if anybody needs it, but that was completed in 2016. We're working on a parallel review right now for the Willow Grove communities. We hope that that's something that we can release later this year. It's been an iterative process as the science has evolved and all the site work has evolved, but again, that's definitely something that we have in the works. We're working a lot with the State Health Department here, and you'll hear some more about that from Dr. Watkins on the state panel later this afternoon. But we're funding their pilot biomonitoring assessment, looking at levels of PFAS in blood in this area. And we've also collaborated with the State Health Department looking at cancer registry statistics for this community. Since about 2015, we've also been working closely with clinicians from the Mid-Atlantic Center for Children's Health and the Environment to do grand rounds and outreach to health professionals here. So we're trying to reach out in different ways through a lot of meetings, basically a lot of meetings. I have a teenager in the house who really, really, really likes The Greatest Showman, that movie. And there's that song, Never Enough, that's blaring at all times in our house. And I think that on a personal level is similar to what we're dealing with here. The science is never enough for us to answer all the questions that we're getting from agency partners and from community members. The outreach we do is never enough to reach everybody that might have a question or a concern, but we just want to leave with you that here at ATSDR and the partners we're working with, we're very committed to continuing to work with you, to listen to you, and hopefully, get some additional answers to these questions. I mean, we struggle every day with families coming to us worried about, in utero exposures or breastfeeding exposures. I mean, there's some very important questions that we haven't really been able to answer fully, and we're looking forward to getting further along in all those areas.
Thank you, Maureen and Dr. Sebelius and Laura. We appreciate you taking your time to spend with us today. We'll now take a break and reconvene at 12:15 with the state panel. Thank you very much.